Hello everyone, welcome back to Quantum Science Hub. In this video, we will discuss IGCSE Chemistry from the last 5 years past paper questions, which is only focusing on the topic about atoms, elements, and compounds. And this is the part 2 video. So, here we go. Question 1. For which covalent compounds does the dot and cross diagram correctly show the outer shell electron? Okay, so we have hydrogen in here and chlorine, right? If you still remember, what is the atomic number or proton number for hydrogen? Yes, it is 1, right? So 1 hydrogen, and how we configure 1 hydrogen? It's just 1, right? So it's mean the first shell contains only 1 electron, right? While in here, it contains of 3 electrons, so it's wrong. And in here, it's contained of 7 electrons, so this is also wrong. So the answer is between option C or D. And in here, we have nitrogen. And what is the atomic number for nitrogen? It is 7, right? So 7 nitrogen, how we configure 7 nitrogen? 2, 5, right? So the first valence electron is already full, which is 2, and the second cell, which is 5, right? So nitrogen contains of 5 valence electron. In here, nitrogen contains of 1, 2, 3, 4, 5 from itself, and 6, 7, and 8. So nitrogen in here is 8, okay? While hydrogen is 2, because hydrogen only contains of 1 cell, so that's why the valence electron is 2, and this is for the hydrogen in here, okay? So everybody in option C is stable or complete, right? While in here, option D, you can see in here, hydrogen is full or complete, while nitrogen only contains of 1, 2, 3, 4, 5, and 6. So in here, nitrogen only 6. So this is not stable because it should be 8 for the second cell, right? So the correct answer here is C. Question 2. Which row identifies the positive and negative particles present in a giant metallic lattice? So let's take a look at the structure of metallic bonding, okay? So this is the structure of metallic bonding. And as you can see in here, this is the positively charged metal ions. And what is the term that we say for the positive ions? So remember, positive ions, it's called cations, while the negative ion is called anions, okay? And for the negative particles in the metallic structure, this is what we call delocalized electrons, okay? So from here, we know the positive particles is cations and it is delocalized electrons. So the correct answer is D. Question 3. Which dot and cross diagram shows the outer shell electron arrangement in a molecule of nitrogen? So remember, nitrogen is the diatomic gas, so it is N2. And what is the atomic number for nitrogen? 7, right? So 7 nitrogen is 2, 5. So nitrogen has 5 valence electron. And how we configure this with another nitrogen? So 1, 2, 3, 4, 5, right? And 1, 2, 3, 4, 5. So in this case, nitrogen have 3 pairs of sharing together in here, okay? So nitrogen at the end will have 5 valence electrons from itself, and 6 and 7 and 8. So in this case, this nitrogen will have 8 valence electrons, which is stable or complete. While this nitrogen at the right side will also have 5 from itself, and 6, 7, and 8. So in this case, this nitrogen will also have complete or stable electronic configuration. So everybody in here is happy. Everybody in here is complete and stable. So which of these options match to this diagram? A in here is wrong because you still have like this, right? You have 2 electrons, again, that doesn't have pair, right? This is gonna be the answer, B, isn't it? While C in here, it's wrong because it has 4, and D is also wrong because it has 6 in here, okay? So the correct answer here is B. Question 4. Which statement about silicon 4 oxide is correct? So let's see the structure of silicon 4 oxide in here. Now let's check the option given. It contains silicon ions and oxide ions arranged in a giant lattice. So it is not ions, okay, but it is silicon atoms, right, and oxygen atom. So this should be atom, right? The same thing with this should be atom. It is used in electrical circuits because it can conduct electricity. No, it cannot conduct, right? Because it does not contain free moving electrons. Its bonds each contain one shared pair of electrons. And yes, that's correct. And each atom are arranged in the same way as the atoms in graphite. No, it's not in a graphite, right? But it should be in diamond. Okay, you may check the previous video which is discussed about the giant molecular structure. So the correct answer here is C. Question 5. The diagram shows the position of elements P and Q in the periodic table. So P in here, this is the first group, right? And this is the second group. This is the third group. 4, 5, 6, 7, and 8, or group 0. So the second group will have the charge of P2 positive, right? While group 7 will have Q negative 1, right? Because to become stable, you should receive or gain 1 electron. While P in here, to become stable, you have to give or lose 2 electrons. Okay? How we draw this one? P will give 2 electrons, right? So in this case, we need 1 P and 2 Q. And because it is group 7, that means it has 7 valence electrons, right? So 1, 2, 3, 4, 5, 6, and 7. The same with the Q in here. Okay, so at the end, P will lose 1 electron and give it to Q. So at the end, Q will become stable. The same thing with the Q in here. So it's given from P. So everybody in here will become stable or complete, right? Because Q at the end will become 8, while P in here, we can see this one. This is the first period, this is the second period, and this is the third period. So that means the configuration of P in here is 2, 8, 2. While we remove the third cell, and P will also become stable, right? So P will become 8 and Q will also become 8 or full and complete. So how many P we have in here? We have 1 P and we have 2 Q. So the correct answer here is C. Question 6. Which statement about ionic compounds is correct? Now let's take a look. Option A. Giant lattices are formed when ionic compounds crystallize from solution. What do you think about this? Is this correct? Yes, that is correct. Because when an ionic compound dissolves in water, its ions, which is positive and negative, move freely. When the water evaporates, these ions come closer together again. The positive ions will attract the negative ions strongly, so they arrange themselves in a regular repeating pattern. And this repeating 3D pattern is called a giant lattice crystal structure. Now option B. In all ionic compounds, the metal ions have fewer electrons than the non-metal ions. Is this correct? Not really, okay? Let's take one example, potassium fluoride. So potassium here is the metal and fluoride is the non-metal. So what is the atomic number for potassium? 19 potassium, right? Then the electronic configuration is 2881. So it's better to lose 1 electron and the valence electron at the end is 8. So potassium in this case, the proton number is 19 while electron is 18 because you lose 1 electron and it will transfer to fluorine. And what is the atomic number for fluorine? 9, right? So 9 fluorine and the electronic configuration is 2, 7. So the 1 electron that is removed from potassium is gained by fluorine. So fluorine will gain 1 electron and at the end, fluorine will become 8. Okay? So fluorine in this case, the proton number is 9 while the electron here is 10. So now you compare, potassium have 18 electron, but fluorine at the end will have 10 electron. Okay, so option B is wrong. C. In a giant lattice, ions of the same charge are closer together than ions of opposite charge. I think this is the general knowledge. As we know, even in magnet, the same pole will repel each other, right? While different pole will attract each other. The same thing with ions. If they are the same charge, it means they will move apart. They will repel each other. So this is wrong. Option D. When ionic compounds melt, strong intermolecular forces are broken. Remember, ionic compounds doesn't have intermolecular forces. Instead, they have electrostatic forces. Electrostatic forces, right? While covalent compounds have weak intermolecular forces. Okay, so the correct answer is A. Question 7. Methanol CH2O has a boiling point of negative 19 degrees Celsius. At negative 20 degrees Celsius, the liquid methanol is a non-conductor of electricity. In a sample of methanol, each atom of carbon, hydrogen, and oxygen has noble gas electronic configuration. Each atom has achieved this electronic configuration in one of three ways: gaining electrons, losing electrons, sharing electrons. Which statement describes the bonding between carbon atoms and the oxygen atom in methanol? So first of all, we have to draw the structure of methanol, right? So what is the atomic number of carbon? 6, right? So 6 carbon, and the electronic configuration is 2, 4. And hydrogen is 1, so it's only 1. And oxygen is 8. So the electronic configuration is 2, 6. And this is the valence electron. Okay, now we have to think about how to draw this structure. Okay, so we have carbon, and we have hydrogen in here, and oxygen in here. And hydrogen we have 1, while carbon we have 4, right? 1, 2, 3, 4. And oxygen we have 6 valence electrons. So 1, 2, 3, 4, 5, 6. Okay, so this is the sharing together. So from here, we know the valence electron of hydrogen at the end is 2. The same thing with this hydrogen in here. While oxygen is 6 from itself and 7 and 8 in here. So at the end, oxygen will have 8 valence electron, which is full or complete, right? The same thing with carbon in here. So carbon has 4 valence electron and 5, 6, 7, and 8 in here. So carbon at the end will also become stable or complete, right? So hydrogen will have single covalent bond with carbon and has double bond with oxygen, right? So now let's check the option in here. Option A, the carbon atom and oxygen atom share 4 electrons. Yes, that is because you can see in here how many electrons that between carbon and oxygen. It is 4 electrons, right? Or we can say it is 2 pairs of electrons. So this is correct. Option B, the carbon atom and oxygen atom share 2 electrons. It is not 2 electrons, but 2 pairs, right? 2 pairs of electrons, or we can say 4 electrons. And this is wrong. Next, carbon is a negative ion and oxygen is a positive ion. Okay, so first of all, what type of bonding does methanol have? The question tells us that methanol has a very low boiling point, which is negative 19 degrees Celsius. And it is a non-conductor of electricity. So these two properties tell us that methanol is a simple molecular substance with covalent bonds. It does not contain ions, so that means it is not ionic bonding. So from here, there is no ion, right? So option C and D is wrong, so the correct answer is A. Question 8. Which statements about potassium chloride are correct? So what kind of bonding is potassium chloride? It is ionic bond. Why? Because it is between metal and non-metal. Let's check each statement. it conducts electricity when solid? No, it cannot conduct electricity when solid, right? It should be in a liquid, okay? The liquid here, it means is a aqueous solution or in a molten state because its ions are free to move. In solid, ionic compound cannot conduct electricity because it does not have free moving ions. Next, it has a higher melting point. Yes, that's correct. Because it has strong intermolecular forces? No. Okay, it should be because it has strong electrostatic. Intermolecular forces is for covalent compound, while electrostatic is for ionic compound. Okay? Next, its structure is a giant lattice of alternating positive and negative ions. Yes, that's correct. And it is soluble in water. Yes, that's correct. Then the correct statement here should be 3 and 4, so the correct answer is D. Question 9. How many electrons are shared in one molecule of nitrogen, N2, and in one molecule of ethene, C2H4? Okay, so what is the atomic number of nitrogen? 7, right? So 2, 5, and this is the valence electron. And carbon is 6, so the electronic configuration is 2, 4. And hydrogen is 1, so it only contains of 1 valence electron at the first cell. So let's throw N2 in here. So nitrogen has 5 electrons. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, right? So this is the bonding, the covalent bonding. So at the end, nitrogen will have 5 electrons from itself and 6, 7, 8, right? So nitrogen in here is stable or complete. The same thing with this nitrogen at the right side, 5, 6, 7, and 8. So from here, I know that nitrogen has triple covalent bond, right? And how many electrons that share together in N2? The total number of electrons shared is there are 6 electrons. So I'm gonna lock my answer between C or D. Next, ethene C2H4. So I have to throw 2 carbon in here and 4 hydrogen. You have to think about the structure and how the bonding to make every element in here stable. So I think we will have double bond between carbon and carbon, right? So 1, 2, 3, 4. And carbon in here is 1, 2, 3, 4. While hydrogen only contains of 1 valence electron, right? So 1, 2, 3, 4. And this is the sharing together, the covalent bond between carbon and hydrogen. So at the end, hydrogen here will complete, which contain of 2 valence electron. The same thing with this hydrogen, and this hydrogen. While carbon is 4 from itself, 5, 6, 7, and 8. So carbon is full or complete. So I can say carbon has double bond with another carbon and has a single bond with each hydrogen. So how many electrons that share together? It's 2, 4, 8, 10, and 12, right? Or we can say there are 6 pairs of electrons. 1, 2, 3, 4, 5, and 6. So there are 12 electrons that share together. So the correct answer here is C. Question 11. The structure of 3 substances are shown. So which substances are hard and have a high melting point? Okay, so from the structure, you should know this is graphite. And number 2 here, this is diamond, right? And this is the structure of silicon 4 oxide or silicon dioxide, okay? So the key idea here, what must you break to melt a substance? Melting requires breaking the forces that hold the structures together. The stronger those forces, then the higher the melting point. Diamond and silicon dioxide, they both are giant covalent structure with strong covalent bonds extending in all directions throughout the entire structure, like a massive 3D network. To melt them, you must break countless strong covalent bonds, and these need a lot of energy. then that is why it is a very high melting point. While graphite has a layer structure. In here, you can see this is the layer structure. So within each layer, carbon atoms are bonded by strong covalent bonds, but the layer in here are held to each other by weak intermolecular forces. To melt graphite, you only need to overcome the weak forces between the layers. The strong covalent bonds within the layers do not need to be broken, and these need much less energy, and that is why it has lower melting point. So the question here, which substances are hard and have high melting point? The answer is diamond and silicon 4 oxide. So the correct answer here is D. Question 12. Which molecule contains a double covalent bond between two atoms of the same element? Okay, so first of all, you have to know what is the molecular formula for carbon dioxide. It is CO2, right? Well, ethanol is C2H5OH, and ethene is C2H4. Nitrogen is a diatomic gas, so it is N2. Now you have to draw it one by one. So carbon dioxide, so one carbon and two oxygen, right? In this case, they will have double covalent bond. 1, 2, 3, 4, and this is 1, 2, 3, 4 as well. And the rest you have to complete for oxygen, which is contained of 6 valence electrons. So in this case, oxygen here is stable because it contains of 6 valence electrons from itself and 7 and 8 from sharing together with carbon. And while carbon here is 4 plus 1, 2, 3, 4 from sharing together with oxygen. So from here we can know this is a double covalent bond between oxygen and carbon. Next, ethanol. So we have 2 carbon and 5 hydrogen and 1 oxygen and the other hydrogen. So in here we have 1, 2, 3, 4, and the same thing with this carbon, 1, 2, 3, 4. While in here we have all single covalent bond. Now from this structure, you can see hydrogen is full or complete, right? Because it has 2 valence electrons, while carbon in here has 4 from itself, 5, 6, 7, and 8. The same thing with this carbon in here have 4 from itself, 5, 6, 7, and 8. While oxygen in here has 6 electrons from itself and 7 and 8. And all hydrogen is also complete because they all have 2 valence electrons, right? So from here, I can simplify the structure is gonna be like this. So this is all a single bond between each element. While ethene, we have 2 carbon and 4 hydrogen. So you have to think about the structure, and I think we already discussed this structure of ethene in the previous question. So this is the double covalent bond between carbon and carbon, right? So from here, you can see hydrogen now it's complete or full, while carbon in here have 4 valence electron from itself and 5, 6, 7, and 8. Right? And the same thing with this carbon in here. 4 from itself, 5, 6, 7, and 8. So I can simplify the structure. This is the double covalent bond between carbon and single covalent bond with hydrogen. While nitrogen in here, it is a triple covalent bond, right? And we already discussed this structure in the previous question. Okay? Now, let's check the question one more time. The question asking about between 2 atoms of the same element. So in this case, you can see option A, carbon dioxide. This is double covalent bond, but this is different element between oxygen and carbon. The same thing with this carbon in here. While ethanol doesn't have double covalent bond. And ethene in here, we have double covalent bond, and it is the same element because it is the double bond between carbon and carbon. while nitrogen contains a triple covalent bond. It is not double covalent bond, right? So the correct answer here is C. Question 13. Silicon 4 oxide is a covalently bonded compound. Which statement are correct? Silicon atoms form 4 single bonds in silicon 4 oxide? Yes, that's correct. As we know, silicon 4 oxide is a giant three-dimensional tetrahedral structure in which each silicon is covalently bonded to 4 oxygen atoms and each oxygen is covalently bonded to 2 silicon atoms. Next, oxygen atoms form 2 double bonds in silicon 4 oxide. Okay, so this is wrong, should be a single bond. Okay, silicon 4 oxide has a high melting point. Yes, this is correct because silicon 4 oxide is a giant molecular structure. Not only silicon 4 oxide, but another giant molecular structure like graphite and diamond also have a very high melting point and boiling point. Next, silicon 4 oxide contains 1 silicon atom and 4 oxygen atoms. As we know, the molecular formula of silicon 4 oxide is SiO2, right? So it contains of 1 silicon and 2 oxygen. Okay, so it is not 4, but it should be 2 oxygen atoms. So the correct answer here is statement 1 and 3. So the answer is B. Question 14. The diagram shows part of an ionic lattice structure. Which compound does the diagram represent? Okay, so first of all, we have to know what kind of bonding is this. This is ionic, right? So ionic bonding, it is between metal and non-metal. Okay, so from here, if you check the option A, B, C, and D, we know potassium is a metal, bromide is a non-metal, and sodium oxide is a metal and non-metal, right? Magnesium chloride is a metal and non-metal, while carbon in here is a non-metal and monoxide. Okay, it's a single oxygen, right? Mono, and oxide is oxygen. So this is non-metal with non-metal. So the answer is impossible if you choose D because this is not ionic bonding. Next, I will just lock my answer between A, B, or C. Look at this diagram. We know the positive charge or the positive ion here is smaller than the negative ion. So to answer this question, we have to know the proton number or the atomic number for each element. Potassium is 19, right? 19 potassium. And bromide or bromine is 35. So potassium is the metal. All metals will have positive charge. So this is the positive and this is the negative. So because the atomic number of potassium is smaller than bromine, then the positive will smaller than the negative charge. Okay, so this is correct. While sodium oxide, the atomic number of sodium is 11 and oxygen is 8. So that means this is the positive and this is the negative. The positive is bigger than the negative. So this is wrong. Next, magnesium chloride. Magnesium is 12, while chlorine is 17. Okay, and this is the positive for magnesium and the charge for chlorine is the negative. So the positive here is smaller than the negative. So this is also wrong. So the correct answer is A. Question 15. Which pair of elements react to form a compound with a strong attraction between oppositely charged ions? So oppositely here means it is a different charge, right? It is between positive and negative ions. And what do you know about these things? What kind of bonding is this? So this is what we call ionic bonding because it is between positive and negative charged ions. And what is the other characteristic for ionic bonding? So ionic bonding, it is between metal and non-metal. Okay, so we have to check which one is metal and non-metal. Option A, carbon and bromine. So carbon, it's a non-metal and bromine is also a non-metal. Okay, so this is wrong. Carbon And nitrogen. Nitrogen is also a non-metal. Sodium, yes, it is a metal. And oxygen is a gas. It is a non-metal. So this is the correct answer. Next, sodium and potassium. Sodium is a metal and potassium is also a metal. So they both are metals. So this is wrong. Then the correct answer here is C. Now it's your turn to solve some of these multiple choice past paper questions. You may pause the video to think for a while and please write your answer in the comment section. I will check your answer and reply every comment. Question 16. Question 17. Question 18. Question 19. Question 20. Next, let's move to the structure question. Question 1. Ionic compounds form giant ionic lattices. Figure 2.2 shows part of the giant ionic lattice structure of sodium chloride. Complete the diagram in figure 2.2 to show the ions present. Use positive for sodium ions and negative for chloride ions. One chloride ion has been completed for you. Okay, so where is the negative chloride ion? Here it is. Okay, so the next one who connected to the negative is positive ions, right? And this is connected to negative. So here is gonna be the positive and here is also positive. So here positive and positive. So who will connect to positive? Negative, right? So here is negative and here is positive and negative. Next, state the name given to any positive ions. Okay, so my way to easily memorize the positive and negative ions, I am using the word cats are positive. So that means cats here have pole, right? So cations are positive, while negative, this is what we call anion. So the answer here, positive ion, is cations. Okay? Question 2. Complete the dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Show outer shell electrons only. So first of all, we have to know what is the atomic number for each of these elements, right? So chlorine is 17. So 2, 8, 7. And this is the valence electron. And carbon is 6. So 2 and 4. And oxygen is 8, right? So 2, 6. And this is the valence electron. Okay, so now let's draw for chlorine. So chlorine has 7. 1, 2, 3, 4, 5, 6, 7. Chlorine here is also the same. 1, 2, 3, 4, 5, 6, and 7. And carbon has 4. Okay, so 1, 2, 3, 4. And oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, and 6, right? You can see in here, chlorine has how many valence electrons at the end? It will become complete N4, which is 8, right? Because it has 7 electrons from itself and plus 1 sharing together with carbon. And the same thing with chlorine in here. While carbon has 4 valence electrons from itself and 5, 6, 7, and 8. So carbon in this case will also become full or complete. And oxygen has 6 valence electrons and 7, 8. Okay, so oxygen here is also complete or full. So I can say this is a single covalent between chlorine and carbon, and it is a double bond with oxygen. Because this is a 2 pairs of sharing electron and this is a 1 pair of sharing electrons. Okay? Question 3. This question is about copper and compounds of copper. Describe the bonding in a metallic element such as copper. Okay, so we have to describe about how is the structure of metallic bonding. And this is a 3-mark question. You can say copper consists of positive ions arranged in a lattice surrounded by a sea of delocalized electrons. The metallic bond is the electrostatic attraction between positive and negative electrons. Okay? Next, explain how solid copper conducts electricity. You can say because it contains of free moving electrons. So this is a 3-mark question. So there are some kind of a keyword that must be exist in your answer, which is positive ions and is surrounded by a sea of delocalized electrons and the electrostatic attraction between positive and negative electrons. For part B, the main idea here, it should be free moving electrons. Okay? Next question. This question is about covalent compounds. Chlorine 1 oxide Cl2O is a simple molecule with covalent bonds. Complete the dot and cross diagram in figure 2.1 of a molecule of chlorine 1 oxide. Show outer electrons only. First of all, we have to know the atomic number of chlorine, which is 17, right? So the electronic configuration is 287 and oxygen is 8, so 2, 6. So we are using 7, 1, 2, 3, 4, 5, 6, 7. And the same thing with this chlorine in here. 4, 5, 6, 7. While oxygen is 6, right? So 1, 2, 3, 4, 5, and 6. So from here, we can see chlorine is complete or full right now because it contains of 7 plus 1. At the end, chlorine will become 8, right? So this and this. And oxygen contains of 6 valence electrons from itself and 7 and 8. So I can say everybody in here are full or complete because the valence electron is 8. Okay? So this is a single covalent bond between chlorine, oxygen, and chlorine. Next, give 2 reasons why liquid Cl2O is a poor conductor of electricity. You have to know to conduct electricity, it should be ionic bonding. And the second one, it should be metallic bonding. And if you see in this question, Cl2O is a simple molecule with covalent bond, right? So that's why it cannot conduct electricity. Ionic bonding means it contains of ions, right? Covalent bonds is a sharing together, so it does not contain of ions. So you can say in here, there are no ions present to carry the charge, okay? And metallic bonding, what is the main characteristic? Why metallic bonding can conduct electricity? Because there are mobile electrons, right? So you can say there are no mobile electrons to carry the charge. So covalent bonds does not contain ions, which is positive and negative ions, and also does not contain of free moving electrons, or we can say no mobile electrons to carry the charge. Okay? Question 5. This question is about the elements sodium and fluorine in the compound sodium fluoride. Some properties of sodium, fluorine, and sodium fluoride are shown in the table 3.1. Explain why sodium conducts electricity when it is a solid. Okay, so sodium here is what? It is a metal, right? So I can say this question actually are asking you explain why metals conducts electricity when it is a solid. So you can say because it contains of free moving electrons or free mobile ions. Okay? Next question. Complete the dot and cross diagram in figure 3.1 of a molecule of fluorine. Show outer shell electrons only. Okay, so what is the atomic number of fluorine? It is 9, right? So the electronic configuration is 2, 7. So we draw 7, 1, 2, 3, 4, 5, 6, 7. While the other fluorine is also 7. 3, 4, 5, 6, and 7. So at the end, these fluorine will have 7 valence electron plus 1, sharing together with another fluorine. So both fluorine at the end will have 8 valence electron, the same thing with this fluorine in here. Or I can say this is a single covalent bond between fluorine and fluorine. Okay? Next, explain in terms of structure and bonding why sodium fluoride has a much higher melting point than fluorine. Okay, so sodium fluoride is what kind of bonding? It is ionic bonding, right? While fluorine here, this is a covalent bonding. Okay, so in this case, you can just explain why ionic bonding have much higher melting point than covalent bonding. So you can say an AF has ionic bonds with strong electrostatic attraction between ions, while F2 has covalent bonds with weak intermolecular forces between the molecules. Ionic bonds are much stronger, so more energy is needed to break them, giving an AF much higher melting point. Okay? So that's all about some past paper question in this part 2 question and answer. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.